All right, thank you. So I'm very excited to join this talk. So we're going to talk about Presto BigQuery Connector implementation. Next slide. So first of all, I'm going to briefly introduce about BigQuery, how it works in the architecture, and then George is going to jump into to explain the implementation of the connector. So if you don't know, BigQuery is a fully managed serverless data warehouse that can process and gain insights from petabyte scale of data very fast. With the help of cloud access control, so you can granular control your access. You can assign permission to users, group, and projects to keep your sensitive data secure, and doing so while helping collaboration across different teams that they're all using BigQuery. So while data at rest, it is secure through encryption and is being put into a durable and highly available storage. Lastly, BigQuery is fully managed and serverless, so you don't need to install or set up anything. So you just you don't actually need a database administrator, so you can just log in and start querying the data. Next slide, please. So this is a picture to show you the BigQuery architecture looks like. So BigQuery primarily consists of 3 parts. There's ingestion, there's querying, and storage. The rest of this, Google handled for you. So in the ingestion part, there are lots of ways to get data into BigQuery. So you can ingest it from a cloud storage, you can ingest from a streaming data, you can use many file formats, if you will, including CSVs, JSON, Avro, Parquet, and more. On the query side, BigQuery is a structured data warehouse. So that means you can use standard SQL to query your data and share the SQL with other users in BigQuery. There are also public data sets that's available. So you can just get started and crunch the data. Google manages the storage for these public data sets. Next, we're going to talk about storage. So data is stored in a structured table, so allowing SQL queries and data analyze. So we manage all the storage, replication, scalability aspect for you. So connecting the storage layer and the compute is Google's petabyte scale network. We also manage large scale of distributed in-memory shuffle, so you can achieve really, really fast performance. Next slide, please. So this architecture shows you how you can utilize BigQuery in the analytics environment. As I mentioned earlier, data can be ingested from many sources in many forms, so batch, streaming, or through the directly integrated Google services, such as PubSub, monitoring. They can just directly integrate into BigQuery. Users will process data using either Dataflow or Cloud Dataproc. Depends on how you want to process, what type of data, and what kind of technology you're familiar with. Data then will be put into BigQuery storage and ready to be analyzed. Therefore, you can start reading a query through the BigQuery, the query engine, or through the BigQuery Storage API. For example, in our talk, we're using Presto in this case. Next slide, please. BigQuery also supports lots of third-party software, so allow you to bring your favorite tool to do your analysis. So next, George is going to talk about how the connector actually works. Good to you, George.
Okay, thank you. So like what Rogers discussed, BigQuery is a fully managed data warehouse on Google Cloud. One of the key characteristics is the disaggregation of the compute and data storage, which by using BigQuery Storage API allows users to read data at scale from other platforms where the data will be processed without the need to first ETL or migrate data from Google Cloud Storage. So in Presto, the BigQuery connector is implemented with the BigQuery Storage API to access that storage directly as shown in this slide. In this particular example, the user with analytical dashboards or predictive applications runs on the Presto for ad-hoc analytical queries using BigQuery connector to fetch the data from the BigQuery storage. The framework for BigQuery connector in Presto implements the encapsulating APIs of Presto's plugin interface. So when Presto server is at launch phase, a plugin manager loads BigQuery plugin via catalog properties files from catalog directory. During connector's installation in catalog, BigQuery connector is registered in a map structure as the type of connector factory, and uses create method to instantiate a new BigQuery connector. And in terms of type conversion, all BigQuery types are mapped directly to their Presto counterparts, with just a few exceptions listed here. Here is to demonstrate how to read the data required for the query in order to optimize the performance of the Presto tasks using this connector. BigQuery connector per each Presto worker in the cluster streams data in parallel directly from BigQuery via gRPC without using Google Cloud Storage as an intermediary. This means that it does not leave any temporary files in the Google Cloud Storage. In most cases, data are partitioned in BigQuery tables by date or integers in similar fashion to Hive, Parquet, or ORC. All rows are read directly from BigQuery servers using an Avro while format. BigQuery uses a columnar storage, which leads a number of advantages for better read performance. Features like columns filtering, which stream data without reading all columns, efficiently reduce the read of data that are only interested. Snapshot consistency, which allows each query read from storage based on snapshot isolation model. Streaming multiple reads, which allows Presto as the consumer to read each row from a table using multiple streams within a section. So with an additional enablement of BigQuery Connector, Presto in both the open source domain and the cloud-based as a service offering allows users to join data across distributed systems for data lake analytics. Enabling the BigQuery Connector for Presto opens up the new use cases in the cloud and adds more functionality to Presto itself. A single Presto query can now combine data from multiple sources using various connectors to data sources in relational, non-relational, and object storage scheme, allowing real-time access to multiple sources data by ease of use, unveiling physical location of data and conjugating into one single federated query engine was impossible, but now with Presto, a rich user interface for data exploration and data visualization, it's a simple piece of user interface of multi-data source management. A user can seamlessly run federated query across large-scale BigQuery instances and other sources, including HDFS, MySQL, Cassandra, Kafka, and more. With Presto's BigQuery connector, user can accelerate data and analysis because Presto takes care of much of the overhead requirement to get started with the Presto. I would like to take this opportunity to acknowledge the contributors who made efforts and contributions to this open source project. Besides myself, many thanks to David, Zhen Xiao, Beinan, and Ro, who provided tremendous support to make it happen in Presto. The project is being merged and planned for availability in release 251 now. If you have any questions or usability issues, feel free to ping in the Presto Slack channel, and we'll be very happy to provide support. Thank you.